Today, we're diving into a piece of gear that's built for one thing and one thing only, to keep you safe from a serious electrical shock. It's called an isolation transformer. But, and this is the important part, this very safety device has a hidden danger that can be, well, pretty lethal.
So here's what we're going to do. First, we'll break down how this thing actually works its magic. Then, we'll see why it's so incredibly important in places like hospitals and repair shops. And finally, we're going to expose the one critical misunderstanding that turns this safety tool into a serious hazard.
All right, first things first. Why does this device even exist? Well, it all boils down to fixing a fundamental problem with the way our normal power grid is set up.
I want you to imagine, just for a second, that you could create your own little personal electrical world. A circuit that's completely, totally cut off from the main grid and its connection to the Earth, but still has power. That right there is the whole idea behind isolation, and it's what makes this transformer so special. Now, this really shows you what's going on. Over on the left, that's your standard wall outlet. You touch a hot wire and boom, electricity sees your body as a super convenient path straight to the ground. You get shocked. But look at the right. The isolated circuit has zero connection to ground. We call it a floating output. Now, if you touch a single live wire, nothing happens. There's simply nowhere for the electricity to go. The path is broken. And this is exactly why they're mission critical in so many fields. In a hospital, it can prevent a life-threatening shock from medical gear. In a recording studio, it gets rid of that awful buzzing sound, that ground loop hum, so you get perfectly clean audio. And if you're a technician working on electronics, it's an absolute must-have on your workbench for poking around in live circuits safely. So how does it pull off this trick? How does it create that electrical bubble? Well, the magic is all in the physics, and there's a specific term for it: galvanic isolation. To put it simply, power gets from one side to the other, but the wires themselves never, ever touch. It's kind of like passing a secret note through a wall without ever opening a door. That total, complete separation is what gives the device its name and its power. And here's the play-by-play of how that happens. It's a really elegant three-step dance. First, the AC power coming in creates a pulsing magnetic field in the input coil. Second, that magnetic field gets funneled through an iron core over to the output coil. And third, that moving magnetic field creates a brand new, fresh electrical current in that output coil. Power is transferred, but there's absolutely no physical wire connecting the input to the output. Now here's a really key detail. Most of these transformers have what's called a 1-to-1 ratio. That means if you put 120 volts in, you get 120 volts out. See, its job isn't to change the voltage like those big transformers you see on power poles. Its one and only purpose is separation. Okay, so this thing is a fantastic safety tool. We've established that. But this is exactly where the story takes a very sharp turn. Because that feeling of being safe, that's precisely what makes this thing so dangerous. You're plugged into this thing. You're floating. You can touch one wire, no problem. You're basically invincible, right? Yeah. That's the thought process that gets people into a world of hurt. Because here's the hard truth. While the transformer protects you from one very specific kind of shock, the kind that goes from a wire through you to the ground, it does absolutely nothing to protect you from the other kind. And this is the most important thing to get. If you manage to touch both the hot and the neutral wires on the output side at the same time, well, the transformer doesn't care about ground anymore. You just became the circuit. You are now the light bulb. It will happily send its full current straight through your body, just as if you'd stuck a paperclip in a regular wall outlet. And the scary part is, the dangers don't even stop there. Because the output is floating, a safety device like a GFCI on the input side is totally blind. It can't see what's happening. So if a tool you're using has a fault, its metal casing could become fully electrified, and no fuse or breaker would ever trip. You've essentially created a silent, invisible trap, just waiting for someone to complete the circuit. Okay, so knowing all these risks, how do the pros use these things every day without getting hurt? Well, they don't just plug it in and cross their fingers. They follow a very strict protocol. So the answer isn't to just avoid the tool altogether. The answer is to start thinking like a professional. It's all about verification. You can trust that the tool was designed for safety, but you have to verify that it's actually working correctly every single time you use it. The whole process is really methodical. First, with the power completely off, you do a full visual inspection. Is there dust? Any cracks? Any burn marks? Then, still with the power off, you do your static tests with meters to make sure it's electrically sound. Only after it passes those checks do you ever power it on for the live, dynamic tests.
And this little chart is basically your pre-flight checklist. You use a multimeter to make sure the coils aren't broken. Then, crucially, you check that the input and output are actually isolated. Your meter should read open circuit. After that, you'd use a special insulation tester called a Megger to make sure the insulation can handle high voltage without breaking down. And finally, a quick voltage check to make sure that 1-to-1 ratio is holding steady.
So after all of that, what's the one thing you really need to walk away with? It really just comes down to understanding the true nature of the tool in your hands.
Look, it offers a very specific and very valuable type of protection, but it is not a magical force field that makes electricity harmless. Relying on it blindly without truly getting its limitations is just asking for trouble. It's a tool that demands both respect and knowledge. At the end of the day, no piece of gear, no matter how expensive or well-designed, can ever replace a solid understanding of how electricity works and a healthy respect for the power you're dealing with. The hardware is a great help, but it's the knowledge in your head that really keeps you safe.
And that's really the question to ask yourself, isn't it? It's not enough to just know that a danger exists. The real test is whether you change your behavior because of it. It's about shifting from that false sense of security to a true, constant state of awareness. Thanks for tuning in.